In this video, I'm going to teach you how to solve this problem. It says using partial fraction, find the inverse Laplace transform of s squared plus 2s plus 3 all divided by s squared plus 2s plus 2 multiplied by s squared plus 2s plus 5. So, without wasting much of your time, let's start. Solution: s squared plus 2s plus 3, s squared plus 2s plus 2, s squared plus 2s plus 5 is equal to s squared plus 2s plus 3. Using completing the square method, we can, because this denominator, if you notice, trying factorization method will give you a complex number. You can't even factorize it. So the best way to factorize this is using completing the square method. And let me just do it. From quadratic equation, you can make one of the multipliers of the denominator equal to 0 to get so using the completing the square method, you have this will be equal to 2, and then you add the square half of the coefficient of x to both sides. So the square half of 2, which is the coefficient of s, is s squared plus 2s. Square half is 2 over 2 all squared, that's 1, equal to both sides. This side 2 is 1. Sorry, this will be minus 2. Sorry about that. This will be minus 2. Minus 2. Sorry about that mistake. So from the left hand side, we can see that it can be factored. You can factorize it. So this will be s plus 1 all squared. Then 1 minus 2 is minus 1. Moving it to this other side becomes plus 1. So we have been able to factorize this using completing the square method. You can do the same thing for the second multiplier of the numerator. Of the denominator. The second multiplier of the denominator. So this one that we have solved for, let's substitute it. Substituting it, you have s plus 1. Anytime you are not able to factorize, just try this method. It will definitely work. Not all the time. So there are some other things too. But this is what you see most of the time. It cannot be factored. cannot be factorized. So this is it. This is a way to factorize it. So now let's continue. So to convert, we still have to find the partial fraction even after factorizing. That's the reason why we are trying to factorize it. So now this will be s plus 1 all squared plus 1, and then s plus 1 squared plus 4. So this is identical to as plus b over s plus 1 squared plus 1. Most times just know that most times, in fact all the time, the numerator must have a lesser power of s than the denominator. And for partial fraction, this is how you do it when the denominator is to the power 2 plus a number. You now make the numerator as plus b or something s plus b, whatever variable you choose. So let's continue. Plus same thing for the second multiplier, s plus 1. If you still use completing the square method, you get this s plus 1 squared plus 4. So it's not difficult. Now we need to add the right hand side of the equation using method of equating coefficients to find the partial fraction of this. We need to add the right hand side of the equation. So adding it, the denominators will cancel out. You'll be left with only the numerators as this s squared plus 2s plus 3 equal to as plus b s plus 1 all squared plus 4 plus cs plus d s plus 1 squared plus 4. So just so that this video will not be as long as the last video was, you can do this still the same thing, just expand. After expanding, you should get a plus c. After expanding and collecting like them, you should get a plus c on in brackets times s cube plus 2a plus b plus 2c plus d s squared plus 5a plus 2b plus 2c plus 2d all into brackets times s plus 5b plus 2d. So this is what you should get after expanding this. After expanding this, we should get this. And now comparing components on both sides, comparing components on both sides, we have this for s cube components. We have a plus c is equal to 0. For s squared component, you have 2a plus b plus 2c plus d is equal to 1. Let's call this equation 1, equation 2. Then moving on, for s we have 5a plus 2b plus 2c plus 2c plus 2d equal to 2. Then for the constant component, 5b plus 2d is equal to 3. Because you can see from here, 5b plus 2d is equal to 3, as they are both constants. So solving this simultaneously as well, solving these equations simultaneously, this is equation 4. Solving these equations simultaneously as well, from equation 1, you can get that a is equal to minus c, because a plus c is equal to 0. So a is equal to minus c. And put a into equation 2 and 3. In place of a, put minus c. That's just what it means. So let me just check for equation 2. Okay. Equation 2. Equation 2 is 2a plus b plus 2c plus d is equal to 1. Now this is equation 2. So in place of a, me put in minus 2c. In place of a, I have substituted minus c. So that's why it's now minus 2c. Then plus b plus 2c plus d is equal to 1. This is off. So we have b plus d is equal to 1. Equation 5. Now 5a, this is equation 3. 5a plus 2b plus 2c plus 2d is equal to 2. All these things is just to solve this equation simultaneously and get the value of a, b, c, and d. So in place of A putting minus C, we have minus 5C plus 2B plus 2C plus 2D is equal to 2. And then simplifying further gives 2B minus 3C plus 2D is equal to 2. Call this equation 6. 5B plus 2D is equal to 3. From equation 4, 5B plus 2D is equal to 3. So in order to continue solving this, consider equation 5. We can make B equal to 1 minus D. Check my screen is not big enough. From equation 5, we can make B equal to, this is equation 5. B plus D is equal to 1. So we can make B equal to 1 minus D. And keep solving. So put B into 4. That's equation 4. You have 5 1 minus D. You can watch the video over again to get, because the solvings are clear. So the calculation is clear. So you can just watch the video again to understand everything. Plus 2D is equal to 3. 5 minus 3D is equal to 3, and minus 3D is equal to 3 minus 5, which is minus 3D is equal to minus 2, and D, dividing both sides by minus 3, will give you 2 over 3. Now putting D back into equation 4. Putting D back into equation 5. In order to get B, putting D back into equation 5 in order to get B. This is the value of D. B plus D is equal to 1, if you remember. So now B plus 2 over 3 is equal to 1. B is equal to 1 minus 2 over 3, which is equal to 1 over 3. Now we are almost done. Put B and D into equation 6. Two minus 1 over 3 minus 3C plus 2 over 3 is equal to 2. Because from equation 6, 2B minus 3C plus 2D is equal to 2. So we have gotten B and D. So now we can get C from here. C now becomes minus 3C is equal to 2 minus 2 minus 4 over 3. So minus 3c is equal to 0. Minus 3c is equal to 0 because minus 2 over 3 minus 4 over 3 will give you 0. Let's do it. So this will be 2 minus, this will be 3, LCM 3. So this will be 2 plus 4, which is 6. 6 divided by 3 is 2. 2 minus 2 is 0. So you can see we are accurate. And therefore c is equal to 0. And in the same way, recall that a is equal to minus c, which means that a is equal to 0 also. Now that we have gotten the value of a, b, c, and d, we can now substitute to get the final answer. So s squared plus 2s plus 3 divided by s plus 1 squared plus 1 s plus 1 squared plus 4 is equal to 1 over 3 times 1 over s plus 1 all squared plus 1 plus 1 over 3 times 2, because you can remember that d is equal to, the value of d is equal to 2 over 3. So plus 4. And finally, the inverse Laplace transform of this function of s, from here, the inverse Laplace of 1 over s plus 1 all squared plus 1 is from first shift theorem. You can check from first shift theorem. The inverse Laplace is exponential minus t sine t. Then for the second one, the same thing from first shift theorem. The inverse Laplace transform is exponential minus t sine 2t sine 2t. So we have come to the end of this problem. So thank you for watching, and don't forget to like and subscribe to this channel for more amazing videos. See you in the next video.